Okay, for the last section here, you want to solve these radical equations. So for this, if you have the square root of y is equal to 7. So the way to get rid of a square root is to square it, because if you take the square root of whatever squared, they just cancel and go away. So we're going to square both sides. So we would have square root of y squared is just y, and 7 squared is 49. So there's your answer. Y is 49. Is the square root of 49 7? Yes, that's true. You do have to be careful on these though, because for the next one you've got square root of y is equal to -6. And I already told you we can't have negatives. Square root's never going to be negative. It's either 0 or positive, because we're not dealing with imaginaries. So if you pay attention, you just say no solution. Square root can't be negative, so it's done. The thing is though, is if you square both sides, you would have y is equal to -6 squared is 36. Well, so you'd tell me the answer was 36, but the problem is if you do the square root of 36, it gives you +6, not -6. By definition, square root is going to be positive for us, like I said, because we're not doing the imaginaries. So this is actually not true if you check it, because this is the statement it gives. That's not true. Square root of 36 is +6. So this is no solution. But like I said, you wouldn't even have to solve that one. If you see the square root equals a negative, you can just write no solution. You don't even have to do anything. So when you solve radical equations, it's always good to check, just because when you're squaring things turns negatives into positives. So sometimes you get an answer, but it might not actually work, like in this case. So if we have the square root of y minus 5 is equal to 5, again, we're going to square both sides. So it's going to give me y minus 5 is equal to 5 squared is 25. Add 5 both sides, y is 30. So to check that, plug in 30. 30 minus 5 is 25. Square root of 25 is 5. So that does actually check. Let me write it down here. So for the ones with the variables like this, you especially need to check, because again, like I said, when you square things, it gets rid of negatives. So you always want to check these and make sure they actually do work. So we have the square root of 5x plus 6 is equal to the square root of 3x plus 7. The only way they can equal is if the insides are equal. You can think of it as squaring both sides again, or just that the insides equal. So basically 5x plus 6 has to equal 3x plus 7. If you square it, they go away. So solve 5x minus 3x is 2x. And 7 minus 6 is 1. Divide by 2. X is 1/2. And again, you want to check these. So we would have the square root of 5 times 1/2 plus 6 is equal to the square root of 3 times 1/2 plus 7. That is 5 halves plus 6 is 17 halves. Oh, I didn't mean to put an equal sign. So the square root of 17 halves is equal to 3 halves plus 7 is also 17 halves, so that is true. So just be careful on these. Make sure you check your answers so that you're not saying that it has a solution when in fact it doesn't, because you can't have radicals equal to negatives.